Hi, my name is Alexis Bruza, and my contributions included working on the reach portion of the code, as well as collecting dynamic data and doing research.
Hi, my name is Carly Hilbert, and I worked on researching throughout the whole project. I worked on both reports for both the core and the reach proposal. I worked on the core component code, and as well I worked on collecting dynamic data for the reach project.
Hi, I'm Natalie Bruck. I helped collect the core component data and I helped write the core component report as well as the REACH project proposal.
I'm Adolfo Nicoloso, and I contributed by writing most of the code, and my main responsibility was to make sure that the app was working properly and effectively.
With the first button pushed, which is the import image, we need to find and define the file name and file path. And you can see here us defining it and finding the file path, which again is defined as full name. We use the imread function as well as defining im, and then used global variables in order to adapt the graph to match up with the map. And then continuing on, when pushing the import coordinates button, again, we defined file name and file path. We got the file as a CSV, and this allows the user to select the file and input it. We again defined that as a CSV file with the file path and file name. We formatted it in order to have the full length of the data and not let it get cut short, as accurate as possible. And then also defined it to make sure that it didn't include the names of the different points, but rather just the coordinates. The next thing that was done on the app is mapping the coordinates on the actual map itself. We named global variables, as seen the very first thing. And then we're able to find the total number of rows and columns, as seen here. We did a nested for loop and used this to find one coordinate using an index of the rows and columns. And then doing this, we converted the coordinates into pixels by using these equations. And then the very last thing is to scatter the plot and plot each point as the for loop continues until there is no more data left to plot.
And now we will break down the reach component before going into further detail on screen record. Okay, so the first button that we created was a get image button, which would allow us to import the campus map, and we could use any JPG, PNG, or BMP file to do that. And then we created a get data button that would allow us to use the map file we obtained from walking and getting our dynamic time data. And we did this instead of using a CSV like in the core component, because CSVs don't allow us to store dynamic time data, and the time data would allow us to create a structure that we would use in the rest of the code.
And then the third button that we made was a show path, and this took the ratios of the latitude and longitude into XY coordinates, and we did this conversion in a part of the code. And then the fourth button is we found the total time that it took between going different distances. It found the average speed between those two distances, found the total distance walked using the Haversini formula, and then calculated calories burned using weight and height of the user. In the app you can import, you can put in your own data so it can make it for yourself, and then displayed everything in a text box area so you can get everything nice and neat.
Reach component app and its code. To get the image that we used, we just did the same as the core component, and we just adapted it to this app. it's the same UI get file function, which then we use to put a variable im, and then use imRead to actually put out and output the image that we wanted into the access to make sure that everything fits properly. To get the data that we use to do all the calculations, we use the get data button. And because now we're using a .mat file instead of a CSV file, we had to put the load function into a variable to make sure the structure is built properly. And then it was also important to find the name of the structure so that we can use its properties later on. To show the path that was traveled, we had a button called show path. And then what we did here, we just had two empty arrays, plot X array and plot Y array, that we used to put in the values converted using the ratio from the core component. This way, we had two different arrays, one array with the X values, and then another array with the Y values. With this, we can just put them into the plot function, into the axis, and have a line that goes through every single point without having to individually map each one. To do the calculations, we did just one button called calculate, and then we just did four main things, which are to find the total time, to find the average speed, and find the total distance, and then to just calculate the burned calories. Because the burned calories subfunction requires time, we left that for last, and we started with the time. To find the time, because it is a timestamp file, all we had to do was find the field called timestamp and then subtract the first value from the last value of that array. That was going to just give us a duration in MATLAB. To find the average speed, we had to find the array with the field of speed in the file, and then we just put that into a mean function and then rounding that up to have a nice number that we can work with. To find the total distance, we started with an empty array, and then what we did was we first had the for loop that goes from 1 to the length of the file field of longitude minus 1, because we wanted to stop 1 point before the last one. That way, that one is the last distance between the last point and the one before it. We used the Haversine's formula to figure out the distance between each point. For this, we needed the radius of the Earth, and then we just needed to do the calculations given 2 points. Because the formula does give us a distance in kilometers, we had to convert that into meters. And then because it is a for loop and it is inside it, we decided to plug in every distance into the D array, the empty array from the beginning, and then just to get the total distance, we would sum the entire array. To calculate the burned calories, we did a simple formula that uses weight and height given by the user, and the time calculated at the beginning. After all the calculations are done, we just printed the results into a text area on the app.